everybody. I'm Jonathan Brendefur from the Developing Mathematical Thinking Institute, and today I'm going to be talking about context for multiplying fractions and representation. So the number line or the area model. So in this case, let's read this story problem. I have run 3/4 of a race that is 4/5 of a mile. How many miles have I run? So not a long race, but it's going to give us our context. So the first thing to ask is, does this feel like a linear or an area model context? In this case, running is linear. So we're going to use the number line as a visual model, iconic model to represent the situation. So since we're focusing on a mile, I am going to put miles here, and the miles are in fifths. So what I want to do is partition into fifths. That tells me to get 5 sections, I need 4 equal. So partition 2. Might get a little smaller there. Redo that for a second. We do want to be as proportionate and accurate as possible. So sometimes it's okay to edit these. Might be easier to sometimes do it 1, 2, 3, 4, and then that 5th one here for the 1 mile. Now I want to break that into fifths, 0/5, 1/5, 2/5, 3/5, 4/5, and then 5/5. Okay, so that's the 5/5 of the miles. Now the race is 4/5 of a mile. So I'm just going to represent that here with the darker amount right there. And that is going to tell me that is 1 race. So now this is the important thing with fractions. To talk about the denominator, it's how many equivalent units to get to 1. So in this case, when we're talking equivalent units of fifths to get to 1 mile, but in this case, we have 1, 2, 3, 4 equal sections of the race. So these are actually, and I'll represent that in blue, are in force. So the race is actually in force. So 0/4, 1/4, 2/4, 3/4, and the 4/4. Now, I've only run 3/4 of the race. So that represents here in blue, 1/4 of the race, 2/4, 3/4. So I've only run 3/4 of that 1 race. But how much is that in miles? I have to refer to the other reference of 1, which is here. So I've run 3/5. So 3/4 of a race is also 3/5 of 1 mile. So we have 3/4 times 4/5. So the race, the amount that I've run so far, and if you think of it, if it was 1, 4/4, I ran the entire race. 3/4, I've only run part of it. If this would have been half, if I would have run 1/4, then you can see that amount here. It's 1/5 of a mile, 2/5 of a mile, 3/5 of a mile. So here, if I would use the algorithm, it would be 3 times 4 is 12, and 4 times 5 is 20, which is equal to, if I reduce that, that becomes 3/5. You can divide both by 4 there, and you see that relationship right there again. So given a linear context, you want to use a linear model to really understand the relationship and why we're changing from fifths to fourths there, and then back to fifths to get back to the mile. Stay tuned for a second one that's going to talk about a different context and why you use an area model and we use the same equation, the same numbers. So thank you, and hopefully this was helpful looking at this model.